Okay. Okay, good morning, everyone. Just first of all, to sort out my designation, it says in the programme I'm University of Edinburgh. I actually am based at two universities, and neither of them are the University of Edinburgh. My main one is a new university that's been established in Hamburg called the Kinnon Logistics University, which is funded mainly by Klaus Michael Kühne, the majority owner of Kühne Nagel. But I retain a position in Edinburgh at Heriot-Watt University. And indeed, the research I'm going to summarise this morning was done at Heriot-Watt University with the assistance of a man called Andrew Palmer, who is a top-class logistics modeller. So much of the analysis you're going to hear about was done by Andrew. So this predates CO3. It's a project that we called Starfish in the UK, which looked at the potential benefits companies can derive from multilateral collaboration, where you get groups of companies. Now, there are lots of case studies of bilateral collaboration. One of the most celebrated examples of that in the UK is a collaboration between two competitors, Nestle and United Biscuits, fiercely competing in the biscuit and confectionery market, and yet they work together to share vehicles. The logistics managers of the two companies got together. They looked at the products they were moving, very similar products, similar densities, similar types of pallet. They looked at the vehicles they were using, very similar. They then mapped their flows in the UK and found lots of examples of them sending trucks empty in opposite directions. So they now try to minimize empty running by backloading each other's vehicles. They're saving just under 300,000 vehicle kilometers per annum. One of them came up with this statement that, okay, the two companies compete on the shop shelf, but they don't have to compete on the back of a truck. So the benefits of collaboration have been well demonstrated, I think, by examples of two companies working together. There are fewer examples of larger groups of companies working together. Some of you may have seen the report done by Capgemini and the Global Commerce Initiative published in 2008, where they speculated about the structure of logistics systems in 2016 and reckoned that by that stage we would see a new generation of collaborative hubs created with more and more product being channeled through these hubs to give companies a means of consolidating their loads. Well, this excited interest in the UK among ECR UK, which has a large membership of large manufacturers and retailers in the fast-moving consumer goods sector. The IGD, the Institute of Grocery Distribution, acts as a secretariat for ECR. So the ECR group got together to say it would be nice if somebody could investigate the potential benefits to this industry if large groups of FMCG companies worked together to share their logistics. So they approached Heriot-Watt University and asked us if we would act as the honest broker and the analyst to conduct this research. The gentleman speaking at this IGD conference is a guy called Chris Tyas, who's the European Supply Chain Director of Nestle, and he described this study as the biggest distribution study of its kind ever. So it was rather daunting, taking on this work. It, in the end, managed to get 27 companies to submit 1 month of their UK freight transport data, which allowed us then to do this very large-scale analysis. So to do this, we had to develop a modeling tool. It was Andrew who did that work. We then had to collect in the data from this group of 27 companies. So it was data on their flows in the UK, information on the types of vehicles they were using, the warehouses where they were located, the sorts of warehouses that we're using. What was then done was a base case was constructed for every company to test the validity of the data we received and to try to eliminate any anomalies in the data set. There was a pilot study initially, 2009, 2010, for 5 companies, the ones shown in yellow in this diagram. That proved that the model worked, yielded interesting results, and so a decision was made to roll out the study to a larger group of companies. And I suppose we anticipated perhaps getting 12 or 15 companies. In fact, 27 companies volunteered to take part, which we found very encouraging. You know, it suggests that there was a high level of interest in multilateral collaboration. For academics, this was Christmas, you know, because we very seldom get access to such a vast amount of data. You can see the figures there. If you annualize the figures, it would have been equivalent to about 125 million pallets moved per year. If we look at the environmental impacts, it was equivalent to about just over 1 million tons of CO2 emitted by all of these transport operations. The collective UK annual sales of these companies over £200 billion, and it represented about 8% of all road freight movements in the UK. So it's a very large database. I mean, some of the model runs were taking several days to complete. So in all, there were 271 warehouse locations. So a very large proportion of all the fast-moving consumer goods in the UK were passing through these 271 points. When we did a preliminary analysis, one thing we discovered, I suppose as you would expect, if you look at the order size profile, there was clustering around 26 pallets, which is the maximum number of pallets you could get onto a typical truck in the UK, or a maximum size truck. We don't have the luxury that you have here in Sweden of having 25-meter longer, heavier vehicles. We're confined to a 13.6-meter trailer and 44-ton weight limit. So that was expected. What maybe was less expected was that there was a preponderance of small orders of 5 or fewer pallets, suggesting there was scope, really, for improving the consolidation of these smaller loads. So the analysis was really in 3 parts. Part of it focused on the individual company's data to validate the numbers, but also to try to assess just how optimal their existing systems were. You know, how well positioned were their warehouses relative to their supply base and to their customer base. There's also some modeling work done of the potential benefits to individual companies of moving to longer vehicles or heavier vehicles, and also rescheduling deliveries. Okay, but that's company specific, and I will not talk any further about that. The focus here really is on the work that we did on the potential benefits of collaboration. And we looked at a number of options. One was to explore the potential for increasing backloading across this group of companies. Another one was simply to transfer product between warehouses to help to consolidate loads. Another one was to create a new generation of regional consolidation hubs. Another one was to make greater use of consolidation centers at the urban level. And then the final one, which relates back to what Sergio was saying a few moments ago, was the opportunities for consolidating flows on interregional movements to increase the chances of using rail. Okay, so just looking at these scenarios in turn. First of all, backloading. Again, we had to impose certain rules. So the priority always was to maximize backloading within an individual company's network, right? Before we went to look for collaborative opportunities. We obviously had to ensure there was compatibility between the load and the vehicle. We assumed that a backload would be at least 20 pallets, so it would be quite a heavy load. There would have to be at least 10 loads a month to justify doing it. We also did cost modeling. we imposed restrictions on the amount of deviation the vehicle could follow to collect a backload. And we also had to ensure that the driver would have had enough time in his daily shift to collect the load. And then subsequently, we relaxed some of these rules. We did a sensitivity analysis. But if one looks at the mid-range estimate, we worked out that you could reduce your transport costs across this group of companies by about 5 or 6%, cut your CO2 by about 8%, save a bit of time as well. I have to qualify these results, however, by saying that this is a shipper's perspective. We were getting our data from the users of the transport services, the manufacturers and the retailers. This is their perspective. What they didn't know was the extent to which a carrier might find a backload, right? So I suspect these figures probably exaggerate the potential savings from backloading. If we had a holistic view of all of this and we could see this from the carrier's perspective, we would probably discover that some of these backloading opportunities were actually being exploited. Moving on to load consolidation, one thing we found was that there was pronounced clustering of distribution centres around strategic locations in the UK. Just under half the warehouses were in 9 zones with a radius of about 35 kilometres. We also looked at the degree of commonality where several companies were supplying the same location. We found there was a good deal of commonality, suggesting there was a potential for collaboration. So one thing we looked at was the possibility of loads being transferred between warehouses within these 35-kilometre radius zones to permit consolidation of movements on trunk deliveries. Again, you can see the rules that we imposed, that this was only for movements of more than 15 pallets. So in the case of that scenario, if that were applied across our group of 27 companies, you would get about a 1% saving in cost, a 1% saving in CO2. Not huge. This is one of the least attractive options. What was much more interesting was the possibility of having a consolidation hub within these 9 strategic zones, where companies, through which companies would channel their products to increase consolidation opportunities on the interregional movements. That would have created much greater benefit, as you can see. So for those part loads that would then be consolidated, you'd be cutting CO2 by almost 20%. You'd reduce costs by about 12% as well. The effect on time would be a bit less because you're adding an extra link, an extra handling operation into the supply chain, so the time benefits are not quite so great. We also looked at this from an urban perspective because a lot of the costs, a lot of the CO2 really comes from the urban end of the delivery. So we, again, speculated that one could set up urban consolidation centres, and either the companies would be delivering directly from their depots to an urban consolidation centre, or we would do the regional consolidation and combine that with an urban consolidation centre. And again, those are the benefits that would be derived from that. Quite substantial. Around 20% of CO2 would be saved. The other scenario I mentioned earlier was looking at the possibility for companies collaborating, consolidating flows on particular interregional corridors to make it more likely the goods would shift from road to rail. So this was our modal shift option. There are 14 intermodal rail terminals in the UK, which are located close to the 9 regional zones. And what we did was we hypothesized that if a certain amount of freight was then consolidated on these interregional corridors, that could then transfer to a train. And we assumed there'd be something like 22 pallets per wagon and about 22 wagons per train. And it did suggest there was a potential really for shifting freight to rail. So at the end of the day, we fed all this information back to the companies. Okay, so we had one-to-one meetings with them where we presented their results. We organized a meeting in London where the 27 companies were represented by senior executives. And we had a speed dating session that day when we encourage the companies to work together. And we put a big matrix on the wall, and 27 by 27 matrix, and we asked companies to use a traffic light system in the light of all of this to say what the likelihood would be that they would enter a collaborative arrangement with one of the other companies. Okay, so if it was a red color they used, then it would suggest they just did not want to collaborate. A green would suggest, yes, we do, there's a good prospect, and yellow somewhere in between. And we were heartened, greatly encouraged by the fact that 40% of the cells in that matrix ended up with a green color. So, in a sense, what we did was the easy part, right? A hypothetical mathematical modeling exercise using company data. The hard part is now for the companies to actually start collaborating, to facilitate, orchestrate, implement all of this. And this is where CO3 comes in, because it's really helping companies now to actually starting to work together. Now, Heriot-Watt University is a member of the CO3 consortium. We're mainly involved in a work package, which, as it says there, is identifying, validating different collaborative business models. Those are the other partners. Much of the initial work has now been completed. Part of it involved reviewing the literature. We were astonished to find that there are over 600 papers written on logistical collaboration. So we've sifted through that huge literature, and we've come up with general conclusions. We've also run 2 focus groups, and there have been about 25 interviews done with big companies in 4 countries. And the results of that work will be published in the next few months. Okay, so that's given you an insight really into our Starfish project. Thank you.
Thank you, Alan. Questions for Alan at this point? Crystal clear. Okay, well, thank you very much, Alan McKinnon.
Okay, great. Thanks.
Hörrni, det är dags för kaffepaus. Vi startar om 10:15. Ta nu rätt dörr, ta den dörren och så går ni i röda mattan så hittar ni kaffe och bulle.